All right, so now it's time for us to talk about one of the trickiest aspects of bone development and the skeletal system. And to get this, you have to understand that bone isn't just its structural functionality. It isn't just a framework for you to hang your body off of and allow your body to move. Bone, we know the inorganic portion of bone is made of primarily hydroxyapatite, which is calcium phosphate, as well as some calcium carbonate. But they're basically calcium salts. And for that reason, calcium is stored in your bones. Calcium's a very important ion in your body. It does a lot of useful things. And your skeleton, in addition to being a rigid body that, helps to protect you and move you around and stuff like that, is also your store of calcium. So the skeletal system is intimately linked with regulation of calcium levels, or calcium homeostasis. So, first off, why do we care so much about calcium? So, calcium is usually not required at very high levels in the body, but it is absolutely required for certain things to function. Probably most obviously, as we'll learn later on this semester, calcium is absolutely required for muscle contraction. And it's required for nerve function, particularly for nerve function in the brain that's involved in learning. It's not generally a part of the standard, nerve action potential nerve signal, but it's an important signal that allows nerves to learn over time and to change their functions. Calcium is essential for blood clotting. Without calcium, your blood won't clot. And on that note, calcium is an essential coenzyme for lots of different enzymes. There are a lot of enzymes that you simply will not function without calcium around. And in fact, they can be turned off and on by regulating calcium levels inside of the cell. So calcium is a very important intercellular regulatory element. You turn things on and off in cells by determining whether calcium is in there or not in there. Normal blood calcium concentrations are 9 to 11 milligrams of calcium chloride, which is the form that it's found in the blood, or of calcium ion, per 100 mils of plasma. That's not a whole lot, but it's a detectable level. And too much calcium can be harmful. Too little calcium can be harmful. It's actually pretty essential that your body keep the calcium levels within that range. Too much calcium can lead to cardiac arrest. Basically, your heart has too much calcium levels, and the heart and smooth muscles actually get their calcium from outside the cell, and too much calcium can cause them to basically contract and then not stop contracting, which if your heart does that, then you die. Too little calcium can lead to pulmonary arrest. Basically, you stop breathing. And if that happens long enough, you also die. So neither of those are good things. You don't want your calcium to get too high or too low. We have terms for that, actually. So hypocalcemia. Remember, hypo means underneath. Hypocalcemia means that you have too little calcium. Hypercalcemia means that you have too much calcium. And this is actually pretty standard nomenclature. Hypo, whatever, means you have too little of that. Hyper, whatever, means that you have too much of that. You will see this nomenclature again later on when we're talking about different ions. But what are the effects of hypocalcemia? First off, so we said that calcium is really important for proper functioning of nerves and muscles. If you have too little calcium in the blood, it causes your nervous system to basically become overly excitable. It becomes too sensitive, and that can lead the nervous system to overstimulate your muscles, resulting in tetany. This is a term that we'll talk about more when we talk about muscles, but it's basically when your muscles clench and then don't unclench. Muscle spasms, cramps, things like that. If this happens in your leg or your arm, it's really, really painful, but probably not life-threatening. On the other hand, if it happens in your larynx, it can basically shut off your airway and cause suffocation. If it happens in your diaphragm, it can prevent you from being able to breathe. Hypocalcemia can have a couple of different causes. First off, vitamin D deficiency. We'll talk about this in just a little bit, but vitamin D is essential for being able to absorb calcium dietarily through the environment. So if you're not absorbing calcium, you will eventually become calcium depleted. Diarrhea. In diarrhea, you actually lose a lot of water, right? Because you're basically pooping out a bunch of liquid. Why is that liquid actually leaving your body? Well, the way your body moves water around is it actually doesn't move the water around by itself. It moves salts around, and then the water follows the salt. Where salt goes, so goes water. Remember that. Where salt goes, so goes water. And salt isn't just sodium chloride. It's any of your body's ions. So with diarrhea, what's causing it is an excess of salts leaving your body into your intestinal tract and taking the water with them. Diarrhea causes deficiencies of all sorts of electrolytes, calcium among them, but it won't be the only one. So diarrhea will cause you to become electrolyte depleted, which can lead to hypocalcemia. Thyroid tumors. All right. So as we will see, there is a part of the thyroid gland that actually secretes a hormone that causes calcium to exit the blood and crystallize on the bone. If you have a thyroid tumor that oversecretes this hormone, then your body will deposit too much calcium onto your bones, and you will have too little calcium in your blood. Last, underactive parathyroid glands. Again, as we will see, your parathyroid glands secrete a hormone that basically causes calcium to leave your bones and go into your blood. If your parathyroid hormones are underactive, then you will not get sufficient calcium exiting your bones and going into your blood, and your blood levels will be low. Pregnancy and lactation. So milk, as we all know, is high in calcium, and if you are nursing and lactating a lot, then that means that you need to get additional dietary calcium. And if you're not getting additional dietary calcium, but you're giving away a lot of your calcium in your milk, then you can become hypocalcemic. Hypercalcemia is much more rare. So having too much calcium in the blood is pretty rare. It has some very severe effects. It makes ion channels less responsive. It makes nerve and muscle cells less excitable. So with hypocalcemia, we saw that the nerves and muscles became overly excitable, leading to tetany, basically cramps where your muscles are going to contract and then not stop contracting. Hypercalcemia does the exact opposite. Your muscles are sluggish, have a hard time contracting at all. And same with your nerves. If the nerves in your brain don't fire off, then your brain, or even if they, don't fire off as efficiency, then this basically produces depression, anxiety, and a huge number of other mental and emotional disturbances. It causes muscle weakness. Your muscles are not firing off as strongly or as frequently. Sluggish reflexes. Your reflexes are controlled by very fast nerves going, basically to your spinal cord and back. If your nerves are sluggish, your reflexes are going to be sluggish. And eventually, cardiac arrest. If your heart, which is a muscle, becomes too sluggish, then it can stop. All right, so that's bad. Hypercalcemia is pretty rare in functionally normal individuals. Usually if you have too much calcium in your blood, you just pee it out. So hypercalcemia is only really going to occur in people who have a severe hormone imbalance, like for instance people who have a parathyroid tumor that is over secreting this hormone that causes calcium to come off the bone and enter into the blood, or in people who have kidney failure and are unable to excrete calcium through their urine. All right, so there are 3 hormones that control calcium levels. There's actually more than 3, but there's 3 main hormones that control calcium levels. Parathyroid hormone, or PTH, and parathyroid hormone causes blood calcium to go up, and bone calcium to go down. So you're taking calcium from your bones and putting it into your blood. We have calcitriol, which causes blood calcium to go up, and it causes a greater intake from dietary. And calcitonin, which causes blood calcium to go down, and it causes it to go down by depositing that on the bone. So it's going to cause bone calcium. The inorganic crystalline matrix of the bone. To go up. And we're going to examine the effects of each of these hormones and how they regulate each other individually. So let's start off with parathyroid hormone. First off, your parathyroid hormone is secreted by your parathyroid glands. Your thyroid is kind of at the sort of the base of your neck. It's in kind of the lower portion of your neck, underneath where your Adam's apple would be if you have one. And your thyroid is a big gland that controls a lot of different things. And your parathyroids, para means nearby or around. There are actually 4 tiny glands that are found on the posterior surface of the thyroid gland. And while the thyroid does a lot of different things, the parathyroid is particularly involved in secreting this one hormone, parathyroid hormone, which specifically regulates calcium. Parathyroid hormone is released in response to low calcium levels in the blood. Its primary function is to raise blood calcium levels. It has 4 ways, 4 mechanisms by which it acts. And you are going to want to know all of these 4 mechanisms. First, it stimulates osteoblasts. Remember, osteoblasts are cells that build bone, but that actually isn't the only thing that osteoblasts do. Osteoblasts also secrete hormones. And in this case, it's stimulating osteoblasts to secrete RANKL. RANKL is a hormone that causes you to increase osteoclast formation. Remember, clasts cleave bone. So more RANKL means more osteoclasts. More osteoclasts means more bone resorption. And remember that bone resorption is when you dissolve bone. If you dissolve bone, then the calcium that was on the bone has to go somewhere. And specifically, it's going to go into the blood. So, parathyroid hormone stimulates osteoblasts to secrete RANKL. RANKL causes you to make more osteoclasts. More osteoclasts mean that you dissolve more bone and release more calcium into the blood. That's number 1. Number 2, parathyroid hormone promotes calcium reabsorption in the kidneys. That means that you pee out less calcium, and therefore you conserve calcium in the blood because you're losing less of it. So blood levels rise because you're getting rid of less calcium. Number 3, parathyroid hormone stimulates calcitriol synthesis in the kidneys. We'll talk about what calcitriol does in just a moment. But calcitriol also raises blood calcium levels, and parathyroid hormone stimulates calcitriol synthesis. thus promoting blood calcium. Last, parathyroid hormone is going to block, I'm going to put a little X there, that means block rather than stimulate, collagen synthesis by osteoblasts. Remember, blasts build, and the way that they build is they lay down the collagen extracellular matrix of bone, and then calcium crystallizes around that collagen. It would not make much sense to promote osteoclast dissolving bone to increase calcium levels in the blood if you also had osteoblasts that were making more bone. There's no point in dissolving bone and making bone at the same time. So if you're going to increase your osteoclast population, then you want to turn off your osteoblasts. We're not going to kill them because we're going to want them later on, but what we do is we tell them stop laying down collagen. Without laying down collagen, there's nothing for the calcium to crystallize around, and it prevents our increased calcium in the blood from just recrystallizing on the bone again. So let's take a look at the actions of parathyroid hormone, right? So this big butterfly-looking thing here, that's the thyroid gland. And see these 4 dots on the back of it? Those are your parathyroid glands. They detect and monitor blood calcium levels. When they sense low calcium levels, they secrete parathyroid hormone. Parathyroid hormone has several ways of acting, right? So first, we said that it is going to stimulate osteoblasts to secrete rank L. So as parathyroid hormone goes and stimulates blasts, which I'm just going to call BL, to secrete rank L. Which stimulates osteoclast, CL, formation, and that promotes bone resorption. When the bone is dissolved or resorbed, calcium is released. Second, parathyroid hormone goes to the kidneys, where it does 2 things in the kidneys. One, it's going to increase the synthesis of calcitriol, which we'll talk about in just a second. And it's going to cause calcium in the blood to be reabsorbed by the kidneys so that it is not excreted in the urine. All of this leads to increased retention of calcium in the blood and increased absorption of calcium from the small intestines, and increased absorption of calcium from the small intestines means that you increase your dietary intake of calcium and blood levels of calcium rise. Second hormone, calcitriol. So we've talked a little bit about vitamin D. When we were talking about the skin, we talked about how the first step, actually the first two steps of vitamin D synthesis occur in the skin. And let's actually talk about that, which is down here for a second. So epidermal keratinocytes are where the first step of vitamin D synthesis occur. They use UV radiation and that converts 7-dihydrocholesterol to pre-vitamin D. You don't need to know 7-dihydrocholesterol to pre-vitamin D. You just need to know that the UV is going to stimulate pre-vitamin D, and then the warming effect of the sun on the skin is going to convert that to vitamin D3. All right? So vitamin D3 is what's made in your skin. Vitamin D3 is actually not the most active form of vitamin D. It's got like a little bit of effect, but it's got to be converted before it's going to have major effects as a hormone. Vitamin D then goes to your liver, and your liver adds a hydroxyl group to it, causing it to become calcidiol. Calcidiol is not the end game here, right? It's also not a very active form of vitamin D. Calcidiol then goes to the kidneys, where another hydroxyl group, a third hydroxyl group, is added, and that converts calcidiol into calcitriol. Ol is the chemical signifier for a alcohol or hydroxyl group. So calcitriol means that it has 3 hydroxyls. Calcidiol means that it has 2 hydroxyls. Calcitriol is the most active form of vitamin D. It is what is going to have the hormonal effect. But what hormonal effect are we talking about here? Well, it does 3 things, but its main effect. So this is its super important effect. So I'm gonna sort of star this here. This is its most important effect, is that it increases calcium absorption by the small intestines. Your bones are your body's repository of calcium, right? That's where your body stores calcium. However, you do pee some calcium out. Even if you're trying not to pee calcium out, you're still going to pee some calcium out. That means that your body is constantly losing calcium. Since it has to maintain a sufficient blood level of calcium or you die, then that means that without absorbing calcium from your diet, you're going to have to keep going back to your bones and raiding them for more and more and more calcium until eventually your bones become so weak that you just start collapsing all over the place, and that's not good. So you need to be able to take in calcium from your diet, and calcitriol is essential to this process. It is what tells your small intestines, specifically I believe that there's some antiporters in your small intestines, and it tells them to absorb calcium. It says, take in more calcium here, please, so that your body can replenish its calcium stores. That's the main effect of calcitriol. It also has 2 less strong effects, and they are similar to and basically help out the effects of parathyroid hormone. right? So calcitriol also promotes osteoblasts to secrete rank L, which we know is going to stimulate the production of more osteoclasts, and osteoclasts are going to cleave bone. Releasing calcium into the blood. Calcitriol is also going to promote kidney reabsorption of calcium ions, so it will reduce the amount of calcium that you lose in the urine, helping you to promote blood calcium levels, to support blood calcium levels. Those are both effects that parathyroid hormone also has. You don't specifically need calcitriol to do those things, though it helps. What you need calcitriol to do is calcium absorption in the small intestine, because parathyroid hormone on its own cannot do that. Calcitriol is also necessary for bone deposition. So, as I said, without calcitriol, eventually you're just going to keep raiding your body's stores of bone calcium to replenish your blood, and that's going to inhibit, it's going to weaken your bones. And if you're a child when this happens, well, your bones have to be growing. When you're a child, your bones are growing a lot. And that means that you need a lot of dietary calcium, right? You may have seen commercials when you were kids or heard when you were kids about how, it's important to get a lot of calcium because calcium makes for healthy bones. Well, that's actually a lot less important for adults. Most adults are not building a whole ton of new bone. We need enough calcium to support the bone that we got. That's about it. If you're a child, you need to have a bunch of calcium because you're making a lot of new bone. And not only that, but you need to be able to absorb that calcium. You can drink all the milk you want. And without calcitriol, it doesn't matter. You're just going to pass through. This is why vitamin D is fortified into milk. Like, if you go to the store and you buy whole milk, it will probably say vitamin D fortified. Remember, vitamin D is what you're going to make calcitriol from. So basically what you're doing when you fortify vitamin D, and cereal, by the way, cereal and bread are both fortified with vitamin D, because it's thought that these are things that you have during breakfast with milk, at least when you're a kid. You're taking in vitamin D, your body will convert that vitamin D to calcitriol, and then that calcitriol will cause your body to absorb calcium from the milk that you just drank. Insufficient calcitriol, which can be caused by either lack of vitamin D or by a lack of the conversion process in the liver or the kidneys, results in bones that are insufficiently calcified. Right? They've still got the collagen extracellular matrix there. You don't have any problem laying that down. Your osteoblasts work fine laying down bunches of collagen, but without sufficient calcium in your blood to crystallize around it, then your bones become soft. In children, that means that your bones don't develop properly. They end up becoming basically really super thin and spindly, and they crack and break easy. And that is called rickets, which we'll talk about in a little bit, in more depth. And in adults, it's less severe because your bones aren't actively growing, but they will tend to decalcify over time, causing them to become soft and fragile, more likely to break, and this is called osteomalacia. Both are caused by the same thing, lack of calcitriol. In children, it results in rickets, and in adults, it results in osteomalacia. Our third hormone that we're talking about right now is calcitonin. And both of the previous hormones that we talked about, parathyroid hormone and calcitriol, act to increase blood calcium levels. Well, we're obviously going to need to have a way to decrease blood calcium levels as well, and to stimulate the body to put calcium onto bones. Everything that we've talked about thus far has been about getting calcium off of bones. Well, you're going to need to be able to put the calcium back on the bones as well. Otherwise, your bones are going to degrade. That is what calcitonin do. Calcitonin is secreted by C cells, which are called clear cells, in the thyroid gland. They aren't the main type of cells in the thyroid gland. There are actually several hormones that the thyroid gland secretes. The main one being thyroid hormone. But calcitonin is secreted by these clear cells in the thyroid gland, and they're secreted when calcium levels are too high. There are two ways that calcitonin lowers blood calcium levels. First off, it inhibits osteoclasts. All right? So it says to the osteoclasts, stop dissolving bone. Second, it stimulates osteoblasts to deposit calcium into the bone. It stimulates osteoblasts to work harder, and it actually is going to cause your body to excrete or to retain phosphorus. Sorry. It's going to cause your body to retain phosphorus. We know that most hydroxyapatite is stored in the form of calcium phosphate. You can have all the calcium in the world, and without phosphate, it won't crystallize on the bones. So it stimulates osteoblasts to lay down more extracellular matrix for calcium to crystallize on, and it stimulates the phosphate levels of the blood to rise so that the calcium can crystallize with something on the bone. Calcitonin is particularly important in children, right? Remember we said that children have quickly growing bones. Children need to be able to deposit calcium on their bones in high levels quickly when they're making new bones. So calcitonin is particularly important to children, and a lack of calcitonin in children will result in symptoms that are very similar to rickets. Calcitonin in adults is less important. You've already got bones, and yes, you do need to deposit calcium on them, but it's a much slower process. In addition, one of the main functions of calcitonin is to inhibit osteoclasts. In children, osteoclasts are very, very active because a part of building bones isn't just laying down calcium, but it's actually sculpting that calcium into place. So you need to lay down bone, and then you need to chip away the excess bone to make sure that your to basically make sure that your bones are the right shape, so they have remodeling going on meaning that they're both building bone and resorbing bone at the same time to sculpt it into the right shape. In adults, that doesn't happen very often. It really only happens when you have a broken bone and it's healing. Well, no, that's not true. It does happen all the time in adults, but at a much slower rate than it does in children. So your osteoclasts as an adult are just simply less active. If they're less active, then inhibiting them is less important. Calcitonin can also help to prevent bone loss in pregnant and lactating women, stimulating or at least preventing your body from losing too much calcium to milk production. So let's take a look at overall calcium homeostasis, all of our hormones acting together, all right? So let's say that for whatever reason, blood calcium levels rise, all right? Blood calcium levels rise. This is sensed by the clear cells in the thyroid that secrete calcitonin. Calcitonin is going to stimulate osteoblasts to deposit more bone, and it will reduce calcium uptake in the kidneys, causing you to pee out more calcium. Blood calcium levels will decline because your calcium is going into your bones and out in your urine. Once it declines to a set point, your clear cells stop secreting calcitonin because your blood has reached its normal homeostatic level. Okay, what about if your blood calcium goes too low? This is sensed by the cells of your parathyroid right here. And your parathyroid cells secrete parathyroid hormone. That parathyroid hormone has 4 effects, remember? It's going to stimulate the secretion of rank L, which causes you to make more osteoclasts, which are then going to resorb bone, right? And from that bone, you have a release of calcium. It's also going to go to the kidneys, where it will stimulate calcium retention, so you pee out less calcium, and that raises blood levels. And while it's in the kidneys, it will cause the kidneys to turn calcidiol into calcitriol, and calcitriol goes to the intestines and tells your intestines, absorb more calcium. And so your intestines absorb more calcium, and that calcium also goes into your blood. All of these things act to increase your blood calcium levels. When your blood calcium levels get to the proper point, about 10 mg per 100 mils, your parathyroid glands sense that, okay, blood calcium levels are fine now, and they stop secreting parathyroid hormone. This is a classic negative feedback loop. As I hinted at earlier, one of the things that we haven't really talked about is phosphate homeostasis. And when calcium crystallizes onto the bone, it isn't just as calcium, right? So you can have all of the calcium in the world, and without phosphorus, it will not crystallize on the bone. So you need calcium and phosphorus working together to get hydroxyapatite on the bone. So a secondary function of many of these hormones is to control phosphorus levels. Basically, if you want to make bone, then you want more phosphate. If you want to cleave bone and raise blood calcium levels, you want less phosphate. in order to prevent the calcium from recrystallizing on the bone. Normal blood calcium or blood phosphate levels is 3.45 to 4 mg per deciliter of blood. You don't need to memorize that. I'll tell you if it's high or low. Phosphate occurs in the body in two main forms, which is like monohydrogen phosphate and dihydrogen phosphate, which is basically like this is a base and this is an acid form. The specific levels of phosphate in your blood are not as crucial as calcium. If calcium gets too high, then you know your heart shuts down, and that's bad. If calcium gets too low, then your nerves don't work, and your muscle seize up, and that's bad. You're going to have, your body's very tolerant to phosphate levels. Phosphate levels by themselves aren't going to have a huge effect on your body. You have high phosphate, you have low phosphate, your body doesn't really care about that. Phosphate is mostly important by how it interacts with calcium. So, calcitriol raises phosphate levels. This is going to be an interesting circumstance where calcitriol and parathyroid hormone work oppositely. All right? Calcitriol raises phosphate levels by promoting its absorption in the small intestines. Calcitriol is going to cause you to absorb more calcium, and it's going to cause you to absorb more phosphate with that calcium. Calcitriol's primary function is to raise blood calcium levels, but you're getting that blood calcium from dietary sources. So if you're getting a bunch of calcium from outside of your body, you want to make sure that you have enough phosphate that if you absorb too much calcium, like let's say you just gorged yourself on milk and cheese, and you got a huge bolus of calcium coming into your blood, you want to make sure that you have enough phosphate that you can store any excess calcium on your bones. Parathyroid hormone lowers blood phosphate levels by promoting the excretion of phosphate in the urine. Why would that be? Well, parathyroid hormone acts to raise blood calcium levels by dissolving your bone, not by getting calcium from the outside. You're dissolving bone. And that means that you don't want phosphate around. If you have high phosphate levels around, that calcium that you just released will just want to recrystallize on your bone. So in order to support high blood calcium levels, you got to get rid of that phosphate so that the calcium is stuck in the blood. All right, last thing that I want to talk about here, we focused on these three hormones, and they are three really important hormones that you need to know, right? Parathyroid hormone, calcitriol, calcitonin. They are by no means the only hormones that affect bone development. There are at least 20 other hormones, vitamins, growth factors, and everything like that that affect bone development. They have like less significant effects, or they have effects for fairly limited amounts of time, but they're still pretty important. They're particularly important in puberty and adolescence, when your bones are growing a lot. So testosterone, estrogen, and growth hormone are particularly important. They are things that your body secretes when you go through your growth spurt, right? When you go through your growth spurt, your body secretes a lot of growth hormone. That tells you, grow, grow. It's going to cause all of your tissues to grow, including your bones. So it will stimulate bone growth. Testosterone is secreted at high levels during adolescence, and in females, that testosterone is converted to estrogen, mostly. And both testosterone and estrogen will promote bone ossification, right? The deposition of calcium onto the bones. Specifically, they do this by, remember when your bones are, well, building new cells, there's that osteogenic layer. So in the periosteum, you have the osteogenic layer that is right next to your bone, and then you have the connective tissue layer that's strong and it's got the collagen fibers, and that's on the other side, that faces your connective tissue away from the bone. These osteogenic cells are what are going to become the osteoblasts. So if you're going to make more osteoblasts, or you want your osteoblasts to become more active, then you're going to need more osteogenic cells to reproduce so that they can make more osteoblasts. More osteogenic cells leads to more osteoblasts, and it also leads to chondrocyte multiplication. Remember, chondrocytes are cartilage cells, and particularly in adolescence, we have the growth of long bone by the expansion of the metaphysis, or the epiphyseal plate, and you're going to have that epiphyseal plate. Remember, we talked about the zones, and one is the zone of proliferation, where you have your chondrocytes multiplying to make more chondrocytes, and then the chondrocytes expand, and then they ossify into bones. Well, these hormones, growth hormone, estrogen, and testosterone, are what are going to tell the chondrocytes in the zone of proliferation to multiply, to divide. And they're going to tell the chondrocytes in the zone of hypertrophy to expand and get bigger. So that promotes bone growth and development. In general, estrogen has a greater effect on bone development than testosterone does. And this is why girls usually hit their growth spurt before boys do. So girls will usually start their growth first, and there's a brief period in adolescence where, on average, girls are taller than boys. Males continue secreting testosterone at high levels for longer. So while girls have their, or females have their growth spurt faster, and they reach full height earlier, males will usually continue their growth spurt for a longer time, and so they tend to end up taller on average. Testosterone and estrogen and the other sex hormones are catabolic steroids. They're sex steroids. They basically stimulate, growth and cell change and cell maturation. Anabolic steroids. These are so anabolic steroids are going to be the steroids that you might take for performance-enhancing reasons. These can actually cause the epiphyseal plate to close off prematurely, resulting in an abnormally short stature. So in summary, we had a lot of stuff to talk about this time. All right? You need to know the functions of calcium in the body. And you need to know the effects of hypercalcemia and hypocalcemia. You need to especially be able to recognize those symptoms if presented to you in a case study format. And you need to be able to say, oh, these symptoms are symptoms of hypercalcemia, or these symptoms are symptoms of hypocalcemia. And that will help to inform your ability to then diagnose a problem. You need to know, understand, and be able to explain how parathyroid hormone, calcitriol, and calcitonin interact, and how they each regulate the body, and how they are regulated in the body, and what their specific effects are. You should be prepared on the test for a question that might ask you something about, what would be the result if you had too much parathyroid hormone or too little parathyroid hormone, or in somebody who had a genetic defect where they were producing insufficient amounts of calcitriol, but their other hormones were working fine. Those sorts of things. I'm going to disrupt these systems and ask you what the result would be. You should also be able to diagram and draw out this hormonal regulation system. So those diagrams that I showed earlier, know them, right? You should be prepared for like a short answer or a free response question where I say, diagram the parathyroid hormone, calcitriol, and calcitonin system, and explain how it regulates calcium levels in the blood. That just a hint that might be a question or similar to a question that you're asked to do. You need to understand what the physiological result of disrupting the calcium regulating hormones would be. I just basically told you that. You need to know how, if I say, what happens if somebody has a thyroid clear cell tumor where the clear cells are secreting too much calcitonin and they're not properly responding or regulating calcitonin, so they're just constantly producing a ton of calcitonin. What's the physiological effect of that? You need to understand how the calcium regulators affect phosphate, and particularly how parathyroid hormone and calcitriol affect phosphate differently, and how this has to do with the different sources of calcium that they're getting. And you need to know these other regulators on bone development that we just talked about, particularly the sex hormones, estrogen, testosterone, and growth hormone. And we will talk about estrogen more extensively in a future lecture on bone pathologies when we talk about osteoporosis. So be ready to work that information into what you learn from here.